Hello students, today we'll talk about uh, charge placed on conductor. If we deposit some charge on conductor, what will happen to the conductor, what will happen to the charge, we'll discuss it today. To understand today's topic, we should be knowing the following points. First of all, we should be knowing that for any closed surface, electric flux can be given as closed integration of electric field over surface area, or else it is ratio of total charge enclosed by the Gaussian surface to permittivity of the medium. Secondly, we should be knowing that electric force on any charge can be given as F is equal to QE. And lastly, we should be knowing that electric field due to any surface plane surface charge distribution at any given point is given as E is equal to sigma by 2 epsilon 0. Actually, when you deposit charge on any surface, the surface will have field lines going on either side. And so, if you are suppose on right side, suppose if you are here, say at point A, the electric field intensity is sigma by 2 epsilon 0. If you are at point B, electric field intensity is sigma by 2 epsilon 0, but total electric field of the surface is sigma by epsilon 0. So with this prerequisites clear, we can start with today's. Consider a conductor, and we know that it is already having so many positive and negative charges, but in equal amount, randomly distributed all over the body. What if we put some external positive charge inside? Now, if we can deposit single positive charge, which is not very much possible, but if we can deposit a single positive charge, it will remain wherever you place it, because there is no net charge with the body other than this, and so there is no one to exert force on the deposited point charge. But what if we place two positive charges? Now the two will have repulsion between them, and so what they'll try to do, they'll try to go to maximum possible distance, and so they'll try to go apart and ultimately they'll settle on the surface. What if we deposit three positive charges? Again the same thing, they repel each other and ultimately they'll try to go to maximum possible distance, and where it is possible, on the surface. True with four charges, deposit four charges on the conductor and again they will go to maximum possible distance. So any amount of charge you place, this is true with negative charge also, this is true with 5 charges, 10 charges, 100 charges, where the charges will go, they will go and ultimately they will settle down on the surface of the conductor. So this is how charges will distribute themselves. So ultimately you have charges on the surface, and then you will have this type of electric field lines produced by the conductor. All these charges will produce field line, and if at any point if you look at the field line, you will see that these field lines are coming out of the body perpendicular to the surface. At any point you see, maybe here or here or here, wherever, you will see that electric field line is always perpendicular to the surface. But inside, if you can imagine a Gaussian surface, you will notice that charge enclosed by the Gaussian surface is zero. So flux will be zero, and hence electric field inside will be zero. Though the conductor is producing electric field outside, inside there is no charge, there is no electric field. So again, inner part is having no field line, no field. And how much is the electric field of this charge in the outer part of? So if we imagine a cylindrical Gaussian surface, and if we apply Gauss's law, we realize that there is no electric field on this side. Inside the conductor, electric field is zero, and hence, what is the electric field somewhere here? That electric field is E is equal to sigma by epsilon 0. So outside the conductor, at any point close to the surface, electric field is sigma. So, in conclusion, we can say that whenever some charge is placed on conductor, the charges get distributed on the surface of the conductor, and if we imagine any Gaussian surface inside the conductor, charge enclosed by the Gaussian surface is zero, and hence electric field inside is zero. But outside you have